All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 26 is on the screen. Let's see how you do with that. We started with these kind of warm-ups last week. This is just a quick review, and hopefully that'll bring to mind what we did last week. So get started, please. Then get a Cornell note right after, because today's a packed lesson, so stay focused. It's going to go pretty quick, okay? All right, copy that and go. All right, you should be just about done. Just for the sake of time, I'm going to go over this one more time. We started with this last week, and just want to make sure we are covering some of the components that we're going to need for the next major concept we're going to arrive to. So let me look at 1A. To simplify this fraction, I'm going to show you a different way of looking at this. I asked you to factor each number. But in order to factor it, I want us to think about greatest common factor between 40 and 72. So that number is 8 for both, right? So 8 times 5, and this one is 8 times 9. Now that we have those two factors, and one of them being the GCF, it's easy to see that this is a 1 over 1, or 8 over 8 is 1, and that leaves us with 5/9. Hands if you got that, bless you. Okay. Number 1B. I'm going to factor the numerator. Let's see. I got 21x squared is the same as 3 times 7 times x times x. All right. Question, what is GCF between 7x to the 4th and negative 28x cubed? 7 and also 3x's, right? So I'm going to write 7 times x times x times x. And what does that leave us? This leaves us an x, and right here it leaves us a negative 4. All right. Now, I wrote it like this so it's easier to see giant 1. So watch. What is 7 divided by 7? 1. What else? What is x divided by x? 1. How about x divided by another x? 1. So look at the numerator. What's left on the numerator? Just a 3. Is that correct? 3. What's left on the denominator? 1x and x minus 4. And that's our simplified fraction. All right, if I was to factor number 2, I would use power interest. What's our coefficient here? An invisible 1. So 1 times 24 goes up here. What goes underneath? Negative 5. What two numbers multiply give me 24 that when you add them give us negative 5? Anything? 1 times 24, 2 times 12, 3 times 8. Let's see, 3 times 8. 3 times 8 is 24, but if you add them, that's 11, so it doesn't work. Can we make one of them a negative? If we do, this needed to be a negative, so we can't. So is there anything? Let's write non-factorable. Non-factorable, because we can't factor. Yeah. On top, we have a positive 24, so we need two numbers that multiply to give us that. But on the bottom, we need to get a negative. That means either both have to be negative or one of them has to be negative. But if one of them is negative, that means the 24 has to be negative, and it's not. So that's why it's non-factorable. All right. Next, let's group number 3. Group. GCF for these two is x squared. That leaves us with x plus 3. GCF for these two is negative 1. That leaves us with x plus 3. My factors are x plus 3. What's left? X squared minus 1. However, do you see a red flag on this one? Tell me of the two factors for that one. Yeah, x plus 1, x minus 1. And then you bring down the x plus 3. And these are my factors. Let's go to number 4. And once again, I know I'm going a little bit faster on the warm-up, but it's because we need to get to the session today. We have a lot to cover. We need to solve for y. That means I need to leave y by itself, so I add 9x, add 9x. We're left with negative 3y equals 9x plus 12. What do I do next? Divide by negative 3, divide by negative 3. That leaves us with y equals 9x divided by negative 3 is negative 3x. 12 divided by negative 3, that's negative 4. And have you got that by yourself? Yeah, some of us? Now they want us to evaluate using the domain. What does domain stand for? All x values. How many x values? 1, 2, 3. From this point forward, when they ask you to substitute or evaluate using the domain, I want you to make a table. X and y. The domain is all x's. So I have negative 1, which is here, 0, and the last one, 5. All right, and once again, for the sake of time, I'm going to substitute, and we're going to do this in our noodle. Ready? Here we go. My first value, negative 1. I'm going to substitute here for x. So what is negative 1 times negative 3? Minus 4, negative 1. Next one, I'm going to substitute the 0 now. 0 in here. So what is 0 times negative 3? And that leaves us with negative 4. And last but not least, we're going to substitute the value of 5. What is 5 times negative 3? Negative 15 and negative 4, that's negative 19. Bless you. And that's how we evaluate using that domain. Okay? Does everybody remember what we call all the y values? Very good. That's called the range. The range. Domain is all x values. Range is all y values. Last but not least, let me go over number 5. Read me those fractions, please, Diego. Oh, Alessandra. 2 over 25 plus 3 over 20. All right. So how do I ask you to do these? First factor the denominators. This is 5 times 5. And this one is 5 times 4. So this denominator has 2 5s, but this one only has 1. So I need to add another 5 over here. So that means I need to multiply the numerator as well times the 5. Now this denominator has 2 5s and a 4, and this one only has 2 5s. What is this one missing? The 4, and we multiply the numerator times 2. And now let's rewrite these fractions. The numerator is 4 times 2, that's 8. The denominator is 5 times 5, 25 times 4, that's 100. Plus, this one is also 100. And 5 times 3, that's 15. Common denominator is 100. Focus on the numerator. That is 23, Michael Jordan. And have you got that by yourself? Okay. All right, we'll stop right there. Copy the agenda, please. All right, so the agenda, warm-up number 26, quadratic equations. Tonight's home play is only 6 problems. Last night, I'm not going to give you a near-pot code tonight. There wasn't any home play since we took the pop party yesterday. But this is tonight, so get your phones out really quick, take a picture of that. And if you don't have your phone, I'm still going to upload the video lesson at the end of the day, so you can go to the YouTube channel, get the home play from the video lesson. Okay? Only 6 problems. Okay? And reminder, tutoring after school, it's free. Be there or be elsewhere. Yes? All right. We good? All right, get a Cornell note ready, please. You do need a prayer model. And like I said, today's going to go a little fast, so everybody go like this really quick. Bear with me. All right, here we go. Our objective for today, I can solve and graph quadratic equations. And today we're going to be graphing using square roots and factoring, 3 different methods. I can solve and graph quadratic equations by graphing using square roots and factoring. Copy that and get a fair model going as well. All right, so according to our objective, what's our major concept for today, everyone? Quadratic equations. So we're going to take a little sidestep from what we've been doing with just polynomials, and today I'm going to give you a little glimpse as to what we're going to be doing throughout the school year, but it's going to go really fast because it's completely packed with 3 different things that I want you guys to do today. Okay? So before anything, in your Fourier model, let's write quadratic equations, and here's your definition. Quadratic equations, what are they? They are 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. Now in your noodle, you can probably picture 2 variable equations. Yes? By now you should be able to picture that. Oh yes, Mr. Q, I got this. But if you don't, here goes some examples. X squared plus 3x plus 2 equals y. X squared minus 9 equals y. And y equals 3x squared minus 11x plus 6. Copy that, and I'll elaborate on that. All right, according to the definition, quadratic equations are 2 variable equations. Let's see. Do we have, number 1, are these 3 equations? Yes. Do each of them have 2 different variables? Yes, x and y, x and y, x and y. Highest degree, what? 2. Let's see. What's the degree of this one? 2, 1, 0, 1. The highest degree is 2. This one, 2, 0, 1. Highest degree, 2. 1, 2, 1, 0. And the highest degree is 2. Any questions with the definition for quadratic equations? No. All right, look at the none examples. Before you copy them, though, look at these 2. Tell your neighbor why these are not quadratic equations. Why these 2 are not. Tell your neighbor, please. All right, Alexandra looks like she's got it. Alexandra, why are these 2 not quadratic equations? I'm sorry? Yeah, they don't have an equal sign. They're not equations. What are these then? If they don't have equations, they are expressions. How about this one? Why is this one not a quadratic equation, Jaden? The degree is in 2, and then it's also missing a second variable. That is correct. Copy that. So our hashtags would be, it has to be a 2 variable equation, hashtag 2 variable equation, and hashtag highest degree of 2. All right? So, tonight's home play, I need you to do 3 different things. We're going to be solving by square roots, we're going to be solving by factoring, and we're going to be solving by graphing, which is probably your favorite all time, right? But to get started, I want us to get started baby steps. We're going to start with square roots, okay? So with that said, copy example number 1. Example number 1. Solve using square roots. X squared minus 9 equals y. Just copy that, and I'm going to go over the process really quick. So once again, it reads x squared minus 9 equals y. Writing utensils down, look up to the screen. I'm going to go over the entire process. It's pretty fast. It's like this fast, watch. That was pretty quick, right? Bam. So writing utensils down, you'll copy right after. Okay, here it goes. Thinking caps on, here it goes. To solve this one, you're like, but now we have 2 variables, Mr. Q. I know. Wouldn't it be easier if it was only 1 variable? Yes, that's why the first step is to change the y into a 0. Don't copy it yet, just pay attention. Now it's easier to solve. By doing what? By leaving x by itself. What do I do to leave x by itself? I add 9, and you're just paying attention. You'll copy right after. I bring down the x squared equals to 9. Last step, I need to cancel this squared. How do I do that? The inverse is taking the square root. Whatever I do to one side, I do to the other. That's why this process is called what? By square roots. This cancels this. So what number times itself gives us 9? What other number times itself gives us 9? Negative 3. Positive 3, 3 times 3 is 9. Negative 3 times negative 3 is also 9. So our answer, we're going to write it like this. Plus, minus 3. Copy that, please. Woo! Let's go. Let's go. All right, so let's see. We started with a problem that says solve using square roots. They give us an equation. The first thing we did, we changed the y to what? 0. From there, we needed to leave x by itself, so we did inverse operations. And what is the inverse of a square? A square root. That's why this process is called solve by square roots. And at the end, we got x equals plus minus 3. From 1 to 5, so how comfortable are you with this so far? 5, 5, 5, 4, okay. Let's do another one. Copy this. Example 1Q. X squared minus 64 equals y. X squared minus 64 equals y. Also solve that using square roots. I'm going to give you a head start, see if you can do that by yourself. But before we start, tell your neighbor the very first thing you're going to do. Very first thing. Yeah, first thing, Alyssa, what did you do? Yeah, change it to 0, the y. So x squared minus 64. From there, we need to leave the x by itself, so what do? Add 64 to each side. X squared equals 64. We need to eliminate this squared. How do we do that? Square root. So x equals plus minus. What is square root of 64? 8. And did you get that by yourself? Okay, so let's do another one. Example 1 mega cube. Copy this. 3x squared minus 27 equals y. All right. All right. Get us started, please, Jessica. What do I do? Change the y to 0. So we end up with 3x squared minus 27. Next, continue, Steve. Add 27 to each side. We got 3x squared equals 27. We say that, what do I do next? Divide by 3, divide by 3. X squared equals 9. And of course, at the end, guys, we do what? Square root, x equals plus minus 3. Hands if you got that. All right, do another one. Copy this. Example 1 super Q, 4x squared minus 100 equals y. All right, Fredo, go. Change the y to 0. 4x squared minus 100 equals 0. Christina, continue. I'm sorry? Add 100 to each side. Thank you. 4x squared equals 100. Diego Robo, next. Divide by 4. X squared equals 25. And of course, we take the square root at the end. X equals plus minus 5. From 1 to 5, how comfortable are you with these? Yeah, 5. So we got this, yes? So the first part is solving by square roots. I think we got it, okay? Of course, we're going to give you different looks like this one or this one. Let's do this one. Example 1, Michael Jordan cube. Negative 5x squared plus 9 equal to 0. All right? Since this one's already equal to 0, continue from there. Dylan, what do we do? Subtract 9 from each side. We got negative 5x squared equals negative 9. Valente, what do I do with x? Tell your neighbor, what do we do next, guys? So like that they know. All right. So what's our next step? Zoe, help us out. We need to leave x squared by itself, so what do? Divide by negative 5, divide by negative 5. So that leaves us with x squared equals negative divided by negative is a positive, so I'm going to leave it as a fraction, 9/5. Next, Diego, Rosas. Square root, x equals plus minus. What is square root of 9, guys? 3. What is square root of 5? Decimal, so we're going to leave it as a radical, square root of 5. For right now, we'll leave it like that. That's okay. Eventually, I'm going to show you that we cannot leave a radical or a square root on the denominator of a fraction, but we'll get to those pretty soon. However, process still the same, yes, pretty much. All right? So with that said, we're done with solving by square roots. But what can we concur? That for all of them, what was step 1, everyone? That we made y equal to 0. And that's for all of them. For all of them. All of them. Even this one, they already converted the y to 0. Okay. Copy this one. Example 2. Let's move on to the next method, which is by factoring. Solve by factoring, they give us x squared minus 9 equals y. X squared minus 9 equals y. X squared minus 9 equals y. Step 1 is do step 1 together. Is the same step, which is what? Tell your neighbor, please. Change y to what? 0. Okay, so we got x squared minus 9. Now, writing utensils down, look up to the screen. Earlier, some other of your colleagues got a little confused. They're like, I asked them for the next step. They're like, add 9, add 9. No, that's the square root method, right? But right now, we are in what? Factoring method. So watch. I'm going to trigger your noodle. Ready? Here we go. If I was to cover this, and I asked you to factor this, tell your neighbor the factors of this, please. What are the factors of that? I think Valente's got it. Very good. April's got it. Very good. Diego's got it. Lorena, what are the factors of x squared minus 9? X plus 3, x minus 3. Write that down, please. Tell your neighbor why that's true. Because this is a difference of squares. Difference of squares. How do you get that? For those of you that forgot, let me take the scribbles out of here really quick. How do we get there? For those of you that forgot, here it goes. When you see a minus in a square, see if you can take the square root of this one. There it is, x times x. And we take the square root of that one. Yeah, 3 times 3. And then you put 1 positive, 1 negative. But now we're going to set all this equal to 0. All right, we got one last step. But before I give you the last step, I'm going to elaborate on something. Don't copy this next. I just want you to understand why we do this next step. So writing utensils down, look up to the screen. Ready? Here it goes. If I was to tell you that a times 0, you would say that is equal to what? 0. Yeah, that is correct. What if I asked you 0 times b? What is that equal to? 0. Okay. But what if I said a times b equal to 0? What could a be? 0. Or what could B be? 0. Either this one is 0 or this one is 0. So what am I saying? That if we have something times something equal to 0, then this one has to be equal to 0, or this one has to be equal to 0. Does that make sense? All right. With that same idea, look up. This times this equals to 0. So what does that mean? That x plus 3 could equal to 0, or x minus 3 could equal to 0. Copy that, please. And at that point, we just solve each equation and we're done. Here we go. Minus 3 minus 3, x equals negative 3, plus 3 plus 3, x equals 3. And I want you to write here, these are my solutions because we have 2 of them. They are also called the X-Intercepts, and you'll see that when we get to the graphing portion. These are also called roots, and they are also called zeros. All those 4 names. So let's see the process. What is the first thing we did? Change it to y, yes. From there, we factored this, and it became 2 factors because it was a difference of squares. And then from there, we set each factor equal to 0, and we solve, and those are our solutions. Okay? See how you do with one of these by yourself. Here we go. We're factoring. Example 2q, x squared minus 64 equals y. X squared minus 64 equals y. Help us out, please, Isabella. What's the first thing we do? Change y to 0. We got x squared minus 64, and if you did that step, okay. Next, we need to factor this past someone. What does this become? Who? Anaya? These become what? X plus 8, x minus 8, and all that equal to 0. Hands if you got it to right there. Okay? Next, Jalen, what do I do next? Okay. So you put x plus 8 equal to 0, and then x minus 8 equal to 0. Okay? Thank you, Caleb. All right. So from there we solve minus 8 minus 8, x equals negative 8, plus 8 plus 8, x equals 8. Hands if you got that? All right. Let's crank it up a little bit. Yes. Example 2, super cute. 2x squared minus 50 equals y. 2x squared minus 50 equals y. Bless you. Bless you. Get us started, JP. What do I do? Change the y to the 0, so we end up with 2x squared minus 50. All right, now check this out, guys. At this point, we would do square root of the first, square root of the last, but we can't take square root of 2x squared, and we can't take square root of 50. However, circular noodle, do you see something here that we can do before that step? Talk it over to your neighbor. What can we do here before that step? All right. What do you think, Joel? Divide by 2, or the GCF being what? 2. That is correct. That leaves us with x squared minus 25, and all that equal to 0. Now, can we factor this inside? Yes. Tell your neighbor what those 2 factors are for the inside of the parentheses, please. Yeah, x plus 5, x minus 5, all that equal to 0, and bring down the BFS also. All right, next step. 1, go. Yeah, all these equal to 0, yes? So 2 equal to 0, x plus 5 equal to 0, and x minus 5 equal to 0. Now notice I did put all three factors equal to 0, but is 2 equal to 0? No, so we eliminate that. That's gone. This one we can actually solve because one of them is a variable. So minus 5, x equals negative 5, plus 5 plus 5, x equals 5. These are my solutions. X-intercepts, zeros, zeros, and roots. Okay. From 1 to 5, how comfortable are you with it so far? Yeah? We got this, right? 4 5s, 4 5s? Okay. Look at this next one. Don't copy this one. Once again, what is the first step? 0. What would be GCF for these two? 3. That leaves us with x squared minus 4, and the rest is history, yes? What if they give us this one? Copy this one. Example 2, Shazam Q. 2 Shazam Q. All right. So just to refreshing your memory, tell your neighbor, what is the first step that we've been doing for all the problems? Step 1. It has to be equal to what? For all of them, it has to be equal to what, everyone? 0. But what is it equal to right here? 20. So what do we need to do to make it equal to 0? Everyone. Subtract 20, subtract 20, yes. That leaves us with 5x squared minus 20 equal to 0. Can we factor that already? No. Before we do the difference of squares, can we find the GCF? Yeah, GCF is what? 5. That leaves us with x squared minus 4 equal to 0. Factors of x squared minus 4. Braden, go. Bring the 5. No. Fabian, help us out. X plus 2x minus 2, and all that equal to 0. So 5 equal to 0, x plus 2 equal to 0, x minus 2 equal to 0. This is not true. Minus 2 minus 2, x equals negative 2, plus 2 plus 2, x equals 2. Woo, let's go. Yes. The 5 eliminates because once we set it equal to 0, it's 5 equal to 0. No? Okay. All right. So if you notice, we've been factoring. The first type was by square roots. That was an easy one. This is by factoring. Now it's easy. But what if they give you something like this? Copy that one. X squared plus 5x plus 6 equals y. And everyone, the first step is to do what? Change y to 0, yes. Question, how do we factor this side now? Tell your neighbor, your noodle should have kicked in already. Yeah. So we got 6 on top. What's underneath? 5. What factors of 6 add up to 5? 2 and 3. So we bring down the first term, bring down the last term, and instead of writing 5x, what am I going to write? 2x and 3x. Let's group. GCF for the first two. X, that leaves us with x plus 2. GCF for the last two. 3, that leaves us with x plus 2. So what are my factors here, guys? X plus 2. What else? X plus 3. but then we have to bring down the equal to 0. Tell your neighbor what to do from there, please. What to do from there? Fredo? X plus 2 equal to 0, and x plus 3 equal to 0. That is correct. Solve. X equals negative 2, minus 3 minus 3, x equals negative 3. Woo, let's go. From 1 to 5, I'll comfortable are you with factoring now, okay? So we got square roots, we got factoring. What are we missing? Graphing. Let's go, our favorite. Copy this one, please. Example number 3. So we're like, oh snap, I remember graphing. Oh yes, our favorite. X squared minus 9 equals y. X squared minus 9 equals y. Okay? All right, this is what I want you to do. When you get to the graphing portion, I want you to leave it as is, and next to it I want you to make a table. X, y. All right? The first value that I want you to substitute is in red for the x. It's going to be a 0. All right, so let's find that really quick. Here we go. So if I substitute in here, guys, look up. What is 0 squared? 0. We bring down the minus 9 equals y. So that means if this is 0, that leaves us as what? Negative 9. Are we there so far? All right, next. Now, we already substituted for x. Now we're going to substitute for what? Y. Check this out. I'm going to put a 0 right there for the y. I'm going to take this equation again. X squared minus 9. But now instead of y, it's going to be what? 0. Does this look familiar? Yeah. What methods do you know how to solve that? 2. Square roots or factoring. What do you want to use? Square roots. All right. So plus 9 plus 9. X squared equals 9. Last step. Square root. X equals, what do we have? What's the answer? Plus negative 3. That means, check this out, that 1 0 is going to be for positive 3, and we need another 0 for what? Negative 3. And that's all we need to graph. So let's make a coordinate plane. Here we go. Is that a little crooked? Yeah? Yeah, I think so. A little bit better? Yeah? All right. So, this is our y-axis. This is our x-axis. All right, so let's graph our red point. 0 of x, negative 9 of y. 0 of x, and then negative 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to plot my point right there. Let me graph the other two. This is 3 of x, 0 of y. 3 of x, 1, 2, 3. And there's my other point. And let's graph negative 3 of x, 0 of y. So we go 1, 2, 3. There's my point. And now to graph, we go from left to right, connecting those points, and you can curve it. Look up. I'm going to start on the left side. And that's our graph. Now, how do we know what are the solutions, Mr. Q? Where our graph crosses the x-axis. These two are our solutions. Where the graph crosses the x-axis. Now, those of you that remember back then when you graph these, they're known as parabolas. Parabolas. Because it's a curve. Okay? From 1 to 5, how comfortable are you with the graphing portion? Yeah? Just make a table, substitute zeros for x and for y, and then plot your points. We're going to stop right there. But once again, your home plate for tonight, here it goes. Let me show you again. It's D6 only. So once again, if you feel that you need extra support, I'm going to be here after school for tutoring. But other than that, you should be able to get to these. Yes? Mm-hmm. Yeah, so for the numbers 1 and 2, you need to do all 3 different methods. Yeah. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.